today's lesson, we are going to spend our time together looking at compound events and compound probability. A compound event consists of two or more simple events. Because we're going to be chaining together all of these one-step probability questions that we've been looking at for the last few days, it's best to start out with some kind of organizational structure that helps us maintain quality lists of all of the outcomes that can happen. So in order to start that conversation, we have a really basic example here. Best Buy is selling their top-of-the-line television in three sizes, 45 inches, 55 inches, and 60 inches, and two colors, black and white. How many different televisions can be made from the different sizes and colors? The two main organizational structures that we want to look at are a table and a tree diagram. A table allows you to efficiently and in an organized fashion list everything that could possibly be an outcome of this compound event. So we could have a 45-inch TV that is white, a 55-inch TV that is white, or a 60-inch TV that is white, and then of course the black version of each television. We can see from the construction of the table pretty easily that we have 6 possible televisions available to us after listing them out in all of the combinations. A tree diagram can serve the same purpose. You might imagine why there's 3 branches there to begin with. Those 3 branches are going to represent the 3 different sizes of television. And then off of those 3 branches, we're going to draw 2 more branches from each. It's those 2 branches which are going to represent the colors of each size. So white and black, white and black, and white and black. So each branch from beginning to end represents one of the televisions. So we have a 45-inch white TV. That's if we follow this branch. If we follow the next branch and instead go down, we have a 45-inch black TV. And then the same thing for the next main branch, 55-inch white, 55-inch black, 60-inch white, and 60-inch black. Again, we can see the 6 different televisions, not in the same order necessarily as what we had in the table. That's okay. They don't need to be in the same order, but still listed out in an organized fashion. From either that table or that tree diagram, we can look at some probabilities. What is the probability if I randomly select from these 6 available televisions, assuming they all have the same availability, that I choose a 55-inch television? Well, if I'm looking for a 55-inch television, it looks like I have 2 options for a 55-inch television in those 6. So I'm going to say 2 out of 6, or 1/3. If I'm looking for a black television, it looks like I have 3 options in the black televisions, which of course simplifies to 1/2. But then I get to the actual point of today's lesson, the idea of a compound probability. What if I needed both of those things to be true? Well, you can see by looking at all of the combinations that we had, and I circled those 55-inch ones and circled those black televisions, that the only one that got circled twice was this one right here. So only one of the televisions is a 55-inch TV that is black. This was a really simple example into what can be a really complicated idea. This idea that we can chain together random events and from there try to look at probabilities. It was really easy for us to do this because we were able to list them all easily. But what should we do when we aren't able to list them so easily?